Namaste to everyone. I welcome you all in my YouTube video channel. Today I will discuss on tensor analysis lecture 12, which includes Christoffel symbols. There are two types of Christoffel symbols. Number one, Christoffel symbol of first kind, and number two, Christoffel symbol of second kind. Firstly, I will discuss about the Christoffel symbol of first kind. Christoffel symbol of first kind is denoted by the symbol gamma ij, comma k, or in another way ij, comma k, and defined by gamma ij k equal to half. Way of writing is, first we take del g I k, remaining suffix is j, del x j, plus we take del g j k, remaining suffix is I, minus del g ij, remaining suffix is k, where g I k, g j k, g I j are all metric tensors. Now we shall prove that this Christoffel symbol of first kind is symmetric. Now, interchanging I and j in both sides, j I k equal to half. In place of I we write j k. In place of j we write I, del g. In place of j I k, in place of I j, minus del g. In place of I j, in place of j I, del x k. This will be equal to half by commutativity del g I k by del x j plus del g j k by del x I, minus here g j I, as g I j is symmetric, so g I j equal to g j I. Metric tensor is always symmetric, so we may write del g I j by del x k. This is number 1 and this is number 2. From 1 and 2 we get that right side equal, therefore left side equal. Gamma I j k equal to gamma j I k. So it is proved that Christoffel symbol of first kind is symmetric. Here I j, here j I. Now we shall describe about Christoffel symbol of second kind. The Christoffel of second kind is denoted by the symbol this I j k or I j k, and defined as I j k equal to g h I, first kind jk h. This ghi is the conjugate tensor, conjugate metric tensor or fundamental tensor. Only writing way is that here we get I, here also I, here another symbol H, which will be here H, and JK remains the same. This is the Christoffel symbol of second kind. Now we shall show that Christoffel symbol of second kind is also symmetric. So symmetric, interchanging suffix J and K. Here we write K, here J, here we write K, here J in both sides. So we will get K, J, here G, H, I, here K, J, H. We know that Christoffel symbol of first kind, this is first kind, is symmetric. So we may write here G, H, I, J, K, H, K, J, here J, K, symmetric. So from 1 and 2, we get that right side is equal, so left side is also equal. Equal to, hence Christoffel symbol of second kind is symmetric. Here JK, here KJ. Now we shall solve a problem. Here problem is given that del Gik by del Xj equal to Christoffel symbol of first kind JKI plus gamma Christoffel symbol of first kind IJK. Taking right side, JKI plus gamma IJK. This is equal to half. We have learned here del G Ji by del xk plus del Gki by del xj minus del Gjk by del xi. This is the first plus second half. Here first write del Gik by del xj plus del Gjk by del xi minus ij del Gij by del xk. Here we see that del Gji, as Gi is a metric tensor, so it is symmetric. We may write here Gij equal to half del Gij by del xk. Here metric tensor is symmetric. We may write Gki, that means Gik plus del Gik by del xj minus del Gjk by del xi plus half del Gik by del xj plus del G jk by del xi minus del G ij by del xk. Taking half common, half del G ij by del xk plus del G ik by del xj minus del G jk by del xi plus del G ik by del xj plus del G jk by del xi minus del G ij by del xk. Here del G ik by del xk plus and minus del G ij by del xk. So this and this cancel out. Again, here minus del G jk by del xi, here plus del G jk by del xi. This also cancel out. So this remains half into 2 del G ik by del xj. This and this equal to del G ik by del xj. So this is equal to left side, hence proved. But we have to remember that this formula can be easily framed. Here we get I, so we first write I, remaining jk. Here k, we write first k, then write ij. So in this way we may remember this formula easily. Now we shall prove a problem which includes the relation between Christoffel symbol of first kind and Christoffel symbol of second kind. Firstly write right side. G K H. This is Christoffel symbol of second kind. So we may write G H P. P is any dummy suffix, and I J P. Christoffel symbol of second kind to first kind we have changed. Here we have given a dummy suffix. We may use any dummy suffix. Here GKH and GHP. H is the common, so this will be equal to Kronecker delta PK, Christoffel symbol of first kind P. Here P is the dummy suffix, so value of P may be 1, 1, 2, 2. When P equal to K, then this will be 1 and this will be K. So this will be 1 into Ij K. This equal to Ij K equal to left hand side proved. Now we shall prove another problem in which we get both sides Christoffel symbol of second kind and here conjugate tensor. Since we know that Gij Gjk equal to delta Ik, this equal to 1 for k equal to I, 0 for k not equal to I. Differentiating both sides with respect to xl, del Gij Gjk side 0 as it is 1 or 0 constant. So differentiation of constant equal to 0 implies that del Gij by del XL, Gjk constant, plus Gij del Gjk by del XL equal to 0 implies that Gij del Gjk by del XL equal to minus del Gij by del XL Gjk. It may be written as this, as a Christoffel symbol of first kind. We have already done that problem. Here this will be gamma IJL plus gamma JIL Gjk equal to minus G gamma JLI minus Gjk gamma ILJ, multiplying both sides by GIP. Here we write GIP, here we also write GIP, here we also write GIP. Here is Kronecker delta PJ del Gjk by del XL. Here we take this and this. So I dummy suffix. So this makes, firstly we write Gjk, now write PJL minus GIP. Here J dummy suffix. So this will become Christoffel symbol of second kind, KIL. Here JJII, here JJ. So these are dummy suffixes. So if J equal to P, then 1, otherwise 0. So we may write this is 1 into, in place of J we write P del G PK by del XL. Here we replace J by H, dummy suffix. So we may replace dummy suffix by any suffix. P H L minus, here also dummy suffix I, we may replace I by H. So in place of I we write H, in place of P we write I, and G I K, in place of L we write J equal to minus G H K, Christoffel symbol. In place of P we have written I, H J minus G H, in place of P we write I, Christoffel symbol K H, in place of L we have written J. So this is proved. We shall prove that Christoffel symbol of second kind in which I is the repeated suffix equal to del log root g by del xg. As we know that g is the determinant of the matrices which contains elements g11, g12, g1n. These are metric tensors g21, g22, g2n, gn1, gn2, gnn. If we differentiate both sides with respect to xj partially, del g by del xj equal to, first differentiate first row, del g11 by del xj, del g12 by del xj, dot dot dot, del g1n by del xj. Other rows remain same, g22, g2n, dot 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 dot, gn1, gn2, gnn. Plus, now differentiate second row. First row remains same, g11, g12, g1n, del g21 by del gxj, del g22 by del xj, del g2n by del xj, dot dot dot. Other lines remain same. So we write gn1, gn2, gnn. Now we differentiate third line, then fourth line gradually, and lastly last row, g11, g12, g1n, g21, g22, g2n, dot dot dot, plus del g n1 by del xj, del g n2 by del xj, dot dot dot, del g nn by del xj. Determinant. Now we find the value of this determinant, cofactor of this place into this, plus cofactor of this place into this, and so on. So we may write A11 del G11 by del xj plus A12. A11 is the cofactor of this place. So A12 del G12 by del xj plus A1n del G1n by del xj. So we get the determinant of the first place. Now determinant of second place. Here we consider the second row to find out the determinant. Here second row we get the cofactor A21 del G21 by del xj plus del G22 by del xj into cofactor a to 2 plus dot dot dot, we get a to n cofactor of this place del g to n by del xj, and we get other determinants. The value of the last determinant, we consider the last row. So cofactor of this place is an1 del g n1 by del xj plus an2 del g n2 by del xj plus dot 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 ann del g nn by del xj. So we get the value of all determinants. Here we see that a11 g11, a12 g12, a1n g1n, and so on. So we may write these all terms in short form del g by del xj equal to aij del gij by del aik, we write. Here we have already used j suffix, so this will be del gik by del xj. So here this is the cofactor. We know that the conjugate tensor gik is equal to cofactor aik by determinant of value. So we may write gik equal to aik. So we put here value of this. We may write here gik del g ik by del xj. So we get here 1 by g del g by del xj, here gik. We may write this in the form of Christoffel symbol of first kind. This will be kij plus this will be ijk. So writing this gik ijk plus gik, this jki, here k and k be the dummy suffix. So this is Christoffel symbol of first kind, hence we may convert it Christoffel symbol of second kind as iij. Here also ii dummy suffix, so we may write this as Christoffel symbol of second kind kjk. This is iij, and as a Christoffel symbol of second kind is symmetric, so we may write kj equal to iij plus, here k with the dummy suffix, so we may replace this by iij. So this is 2 Christoffel symbol of second kind, ij, implies that 1 by 2g del g by del xj equal to Christoffel symbol of second kind. Let this is number 1. Now del log root g by del xj equal to firstly log 1 by root g, differentiate, then differentiation of root g 1 by 2 root g square root g, then differentiation of g del g by del xj equal to 1 by 2g del g by del xj. This is number 2. From 1 and 2 we see that this equal to this. So del log root square root g by del xj equal to Christoffel symbol of second kind, this, hence proved. Thank you for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel.